bare stainless body on a $100,000 truck corrodes and rattles for 5 concrete reasons. Marketed as rust-proof, yet owners photographed orange spots within weeks.
It takes 2 minutes to see why. The obvious guess is bad steel. It's not.
Tesla chose a bare stainless exterior on purpose. No paint, no clear coat, no galvanizing, as the truck's signature look. But a raw panel that pits, streaks, and expands means 2 problems at once: cosmetic ruin and structural rattling on a flagship.
One choice caused all of it.
Start with the word itself.
Stainless isn't rust-proof, it's rust-resistant. Here's the difference.
The metal protects itself with a microscopic skin of chromium oxide, an invisible passive layer that reforms when scratched.
That skin is the whole trick.
But it fails when 2 things attack it: stray iron or chloride salts.
And a raw body has nothing else guarding it.
Now the spots owners saw. Tiny iron particles from rail dust in shipping break dust on the road. Even the tooling that shaped the panels land on the bare surface and embed.
Those particles rust.
The orange bleeds outward in what the trade calls T-staining.
The steel underneath is fine.
It's the freeloading iron on top that's corroding, staining the panel like rust that isn't really the panels. On a painted car, paint would have blocked every one of those particles.
Here, there's nothing between the alloy and the world.
Which raises the next question: what happens when the attacker isn't dust but salt?
Salt is where it gets worse.
Winter roads get sprayed with de-icing salt.
Coastal air carries it too.
Both are loaded with chlorides, and chlorides are the one thing that punches straight through that chromium skin. Even good 304 grade stainless isn't immune. The chloride finds a weak point and drills a microscopic hole. That's called pitting corrosion. Not a broad stain, but a deep, narrow pinprick that keeps eating downward. Once a pit starts, it concentrates the attack and accelerates. A painted steel body is sealed against all of this. Paint and primer form a barrier the salt never crosses. A bare stainless exterior takes the chloride hit directly on naked metal. Every drive, every storm.
This isn't theoretical.
Owners in salt belt states, the northern places that dump the most road salt each winter, report the fastest visible corrosion showing up first and spreading widest.
Same alloy, harsher chemistry, quicker failure.
So the surface streaks and the salt pits. But owners complained about something you can hear, not just see.
That sound is failure number 3.
Metals grow when they heat and shrink when they cool. Stainless steel does this more than the aluminum and steel frame it's bolted to. So on a hot afternoon, the outer skin expands further than the structure beneath it, and every night it pulls back. Different parts moving different amounts, over and over. That constant push and pull slowly loosens how tightly each panel sits.
Now add the shape.
These panels are large, flat, cold-rolled sheets, and big flat metal behaves like a drumhead. Press it and it flexes, a wobble called oil canning. Drive over a bump and it resonates, booming and buzzing.
That's the rattle owners describe.
One more thing makes it louder. The gaps between panels were drawn razor-thin for looks.
Tight gaps photograph beautifully.
But they leave almost no room for metal that's constantly expanding and contracting. The design left the steel nowhere to move.
So it moves anyway against its neighbors.
And there's a quieter failure hiding where those panels meet.
Look at the joints.
Put 2 different metals in contact with a little moisture between them and you build a tiny battery. One metal gives up its atoms to protect the other, and it corrodes faster than it ever would alone.
That's galvanic corrosion.
The Cybertruck is full of these pairings: steel fasteners and aluminum substructure, stainless skin all touching.
Every contact point is a potential couple.
Then trap water in the seam. Rain and wash water seep into panel gaps and pool around the glued, bonded joints, and it can't drain or dry.
Now that little battery runs all day. This is the turn that matters.
The T-staining and pitting were mostly cosmetic, ugly but on the surface.
This is different.
Galvanic attack works at the fasteners and joints that actually hold the body together.
It eats where the truck is bolted and bonded. So the corrosion stops being just a stain you can see and starts being weakness you can't.
Which leaves one problem no owner can wash away.
Here's the trap.
On a normal car, damage is fixable. Sand it, fill it, repaint, and the color hides the seam.
You can't do that here.
The finish is a uniform brushed grain across bare metal, and there's no paint to blend into.
Touch it up and the repair shows forever. Filler shows. A new grain never matches the old. So staining and scratches are essentially permanent, or they mean replacing the entire panel. Even keeping it clean is a chore. Fingerprints etch. Water spots set.
Contaminants need special cleaners, and Tesla itself told owners to wash off road grime promptly before it embeds.
Think about what that means.
The bare metal look is the whole identity of this truck, the thing every photograph captured. That same bare metal is what makes it unforgiving to own, and nearly impossible to fix once it's marked.
The design that made it iconic is the design that made it fragile.
Every failure so far points back to a single decision. So here's the whole mechanism. 5 failures, 1 root cause, choosing a bare, uncoated stainless exterior for the look, skipping the paint, primer, and clear coat every other production car wears.
That coating isn't decoration. It's the barrier.
Remove it and the same panel faces iron dust, road salt, daily heat cycling, and dissimilar metals with nothing in between.
The chromium skin stains. Chlorides pitted. Heat rattles it. Joints corrode. And none of it repaints.
Rustproof was never a promise stainless could keep on a raw body in the real world. That word describes the alloy in a lab, not a truck in a salt belt winter. The orange streaks and the rattle over bumps aren't defects that slip through.
They're the predictable physical price of the signature bare metal aesthetic. The shine and the flaw are the same surface. The shine is the flaw. Bare stainless traded protection for a look, and every failure grew from that one trade.
So the real question isn't whether it corrodes, physics settled that.
It's whether the aesthetic was worth it to you.
Next time, we open up why paint on your everyday car is doing more work than you ever noticed.